Yeah, I think it's awesome.
What's really cool about streaming tables, it's the semantics of it under the covers.
Just writing a bunch of queries.
The managed state.
So you add files in the volume, raw files, raw JSON. All right, guys, thanks for listening. Today I'm with Franco. Franco is the lead product specialist at Databricks. He's our expert on data warehousing and SQL. Thanks so much for taking the time with us today, Franco. Do you want to present yourself maybe quickly?
Yeah, hey everybody. My name is Franco Patano. I've been working at Databricks for about 5 years now, helping the world of warehousing understand this whole Lakehouse concept and now accelerate into data intelligence. And I'd love to help you all see how we've improved SQL over the years.
Awesome. Yeah, SQL is a big new thing for Databricks. I think I remember when I joined 4 years ago, it was mostly data engineering plus a bunch of notebooks. So, just kind of the Spark open source version with some optimization, plus notebooks to run the AI in the ML. And since then, a lot of things changed. Like we added SQL and a full warehouse support. Maybe Franco, we can start with a recap of what happened over the last few years at Databricks.
Absolutely. I tell this story every now and then, so I've kind of got a couple slides on the matter. Happy to walk you all through this. So back in 2018, the founders kind of noticed something. They made SQL available to users, and they were using it more and more. And then along 2018, Delta Lake came out. Back then it was just Delta, and it exposed to do DML or data manipulation with the SQL language. Think like insert, update, delete, and merge on the data lake with SQL. And we noticed that customers loved that and they started using it more and more. But they kept asking us, we have all our data on the data lake. We have to copy it to the warehouse to get fast BI serving. Can't you give us the performance we like out of the warehouse on the lake so that we don't have to have both? And so that's where Lakehouse came from. We were like, sure, we can essentially build the performance of a warehouse right here on Databricks so that you could have the best of both worlds. And that's kind of where that thought leadership came out in 2020. And essentially since then, now everyone else is joining the bandwagon and they're saying, no, we have a Lakehouse. But really, these all seem like fake houses, more like warehouses that are putting on a new coat of paint. But what we've done over the past 3 years that we've been bringing Databricks SQL to the market is we've been hiring an amazing teams of engineers across the globe to help us build this system, to build Lakehouse and now data intelligence platform. And it's been amazing. It's been quite the journey. When I first joined Databricks, I was helping customers build these, SQL computes out of all purpose. I've written blogs, I've done talks, I've kind of helped customers stitch these things together. And then in 2020, I think 2021, we broke the world record in data warehousing query serving. And that was with our classic data warehouse, DB SQL. And our customers kept asking us for more. They were like, yeah, that's great, but I still have to manage the compute and the storage, and I still have to do all these configs. Can you make it simpler? And then we came out with serverless in 2022. And customers were just very happy with that. We're getting very good performance there, and they don't have to manage as much. And now they keep asking for more. Can't this platform, you guys are masters of AI. Can't you just have AI manage everything, give us great performance, make the usability awesome? And that's where we're going, is we want to build kind of the self-driving version of the platform. So just to give you an idea of what was built over the past 3 years or what the impact of it, in 2020, you can see here performance was not great compared to the best, one of the good data warehouses on the market. And in 3 years, we were able to 4x that performance, now leapfrogging the competition in throughput. And this is price performance. So we're not spending money to get better performance. This is cost effective. But then not just on big data, but another concern customers is like, how about as the users scale up? Because what they've noticed on these other vendors with these warehouses is as they start exceeding about 100 users, the performance is not great as it was when there were low users, and they kind of had to keep pouring more money into the warehouse in order to get good performance. And whereas our engineers took a look at this and we solved the problem a little more elegantly, and we kind of get the same performance as the number of users scale. So this was very important to customers. How did we do that? There is a significant long tail of projects that this amazing team, engineering teams that we've hired over the years have done. So I don't want to diminish all of the hundreds upon thousands of things that were done, but three big ones. First off, I've written blogs and done talks about how you tune your files, about how do you tune Delta Lake performance. And the first thing they did was like, can't we do auto tuning? Can't we just have AI manage that stuff? And absolutely. We now call it predictive optimization, and it just does itself. The second one was how does the warehouse manage all of the different types of workloads that are coming in? You used to have to size it manually. I actually have one of our very early customers has a Databricks job that resizes the warehouse every part of the day, depending upon their demand. And they're like, why did we have to build all this? Can't you just have AI do it? And we did. We built intelligent workload management to basically meet the demand that's currently coming against the warehouse where it is, like bring the compute up to match that, to make it scale better. And then, having to manage how you get good query performance is a very complex problem in other warehouses. You have to do like indexing or clustering, and this is very complex things. And you have to pay for that. Every time you try to do like an index or a clustering or a search optimization, the vendor charges you money to do that, and it actually can be quite expensive. Our team looked at, can we do a suite of techniques that enables the same type of performance without having to have the customer pay for it? And that's predictive IO, and customers really appreciate that. We're able to get very similar performance that other vendors that they charge you for to get there by rewriting your data. We're able to get really close to that without having to do all that. And not just there, some of the things, one thing that we're going to talk about today is streaming tables and materialized views in order to build what I call streaming warehouses. Traditionally, warehouses was batch overnight processing. It's kind of where it came from because the amount of compute that it took 20 years ago to process all this data was pretty intensive. And during the business day, that compute needed to be used to serve the data to the business, so they couldn't have it running then. So they had this batch overnight processing. But the business needs data right now. They can't be using yesterday's data. The competition is using real-time data. And so streaming tables helps you do that. And that's the demo I'm going to show you today is how can you build streaming tables in Databricks SQL. And then also, how do you get good performance on your BI reports? And this is materialized views. A lot of other warehouses have this. Ours has some secret sauce under the covers to make it really efficient incremental computation, so that you're not having to pay a lot of money to keep these materialized views up to date. And both of these concepts are natively supported within dbt. And so typically people used to think that there was, Delta Live tables and dbt compete. They absolutely do not. You can use streaming tables and materialized views inside of dbt to make your pipelines more durable and in real time. Because if you've ever tried to do state management or incremental consumption in dbt, it's really, really difficult. And now we make it super duper simple. So that's a little bit about the capabilities of the platform that we've been working on, kind of the story of where we are. What do you think, Quentin?
Yeah, I think it's awesome. And the streaming tables, like it's incremental, but you don't have to, like, it doesn't have to be up and running every day. You can do every hour. Like you can change the needle based on kind of price and freshness. Is that correct?
Yeah. So what's really cool about streaming tables, it's the semantics of it under the covers, the managed state. Like one of the hardest problems in data warehousing is where did this pipeline leave off? Where do I pick up and start processing from here? With streaming tables, you call what I call ultimate state management for free. Basically, the streaming checkpointing automatically keeps track of where you are, and Delta's transaction log knows like where everything is, and you get automatic state management like out of the box, which is, I mean, for a data warehousing person, it's like a huge relief off of them that they don't have to even think about this, because usually they were doing like last process date and doing like really weird things with date and times, and it's very complicated. So I think streaming tables and as well as materialized views, it actually brings really awesome capabilities efficiently and brings it to the analyst community or the warehousing community in a very cost effective way.
All right, and so the materialized view will use, so they will do incremental recomputation when they can. Like I think a simple example would be you create the average, then the state will keep for you like the sum and the counts, and we will just do like an incremental update. And we do that with a bunch of techniques to make sure that we avoid any expensive recomputation. Is that correct?
Yeah, the overall project is called Enzyme, but essentially, we there's all these different ways that you can update data depending upon the incoming data and the logic. But in order to do that, you need to understand the pipeline, the end to end of what's happening on this, in order to determine what is the best mechanism to do that. Is it partition recompute, full reload, all of these different capabilities? And essentially, Enzyme is built inside of the underlying mechanism that drives streaming tables materialized views, which is delta live tables. It does all that computation and hard math and difficult things to understand what is the cheapest way to incrementally process this materialized view, and it does it that way. So it's actually really efficient. What I like to call fast and cheap, which are two very important dimensions that customers appreciate.
Yeah, it feels like Databricks is filling all the gaps. How do you think Databricks SQL is doing compared to maybe the top warehouse on the market out there?
I'm cheating a little bit because they just had their public quarterly, I think yearly results just published, and they said the best data warehouse on the market is trying to build capabilities like Databricks and what they call Snowpark, which is a snarky take on Spark. Uh, but essentially, their business is less than 100 million on them trying to come into our territory. I think the last published number that Ali gave publicly, that I can publicly say, our warehouse hit 250 million last year. I believe was the last number he publicly stated. So the number as of today is larger than the last publicly referenceable number. And I can safely say that we are more than 3x into into the leading cloud data warehouses market than they are in our market. So if that's any gauge of how well we're doing, we're 3x better than what they're doing on our turf.
Yeah, so your take is Databricks is moving much faster into SQL and warehouse than they would be moving into maybe data engineering and AI. Is that what you're saying?
That's what I'm seeing, and I like to sum it up like this to best understand it. Data warehousing is a solved problem set. We have solved data warehousing. There are papers, academic papers, researchers. We've solved all the problems of data warehousing up until today. So it's all like what I like to call solved problems. We just have to implement them the best way possible on Databricks. Data science, machine learning, and AI is not a solved problem. It's a very, very hard problem to go after. And you need really, really smart engineers and leadership in order to do it. And Databricks has been executing on the hardest thing, the unsolved problem, for a very long time. To really add on solved problems to a platform that delivers the complexity of AI is trivial. In order for a warehouse company to add this unsolved problem of data science, machine learning, AI to their stack it's good they're going to have a harder time doing it, right? It's just we're basically adding unsolved problems to the platform as fast as possible. I just think about that for a second, right? It makes sense.
All right, so SQL is easy and AI is hard. Okay, sounds good. Let's see what we can do with the SQL warehouse then. Do you wanna start a quick demo to show us how we can create the streaming table and the materialized view and maybe run some exploration on top of that?
Absolutely. So here I have Databricks Unity Catalog pulled up. This is the one-stop shop to what you need in Databricks, right? So whatever you need, usually it comes from Unity Catalog. And I think you can't do data warehousing without Unity. Anyone that tells you otherwise is wrong. So here, what I've done is we've set up raw landing of this data that comes in from the system, where the device data lands in a volume. And essentially, in that volume is where all of the data goes. So what I'm going to do is I'm going to ingest the data from the volume here into a streaming table. So there's just a folder full of JSON files, right? And then I'm going to ingest that data into my ingestion schema into two tables. I have my IoT devices stream. And so this is those JSON files that are coming in for these devices. What are they? think like wearable exercise things like your Fitbit, Apple Watch type things. They are users, and it's tracking all of their calories burnt, steps walked, and stuff like that. Then I'm going to ingest data about the users. So I have various metadata about these users, their gender, age, and other metrics about them to understand who they are, right? And so I have all of this data being ingested, and I want to be able to use it. So off the bat, I just want to kind of show some really cool things about Databricks while we're here. I've kind of had some of the comments about what this data is. It's a streaming table for IoT devices. But then if I want to define the columns, I can click this AI generate button here, and it will essentially give me the definitions of these columns by itself. So now I have really well-defined metadata, and it was super duper simple. Then one of the other biggest problems that happens is lineage. And here I'd like to show you just what that looks like on Databricks. Here I have end-to-end lineage. So my data came from that volume where I had all my files being landed, and then my streaming table here where all my data gets ingested to, and then it's going to my actual materialized view that this is where my data is going to end up, where I'm going to be querying it for consumption. What is that? And so just to kind of go over what this stuff looks like, let's just take a look at the code real quick before we dive into the data, build a quick dashboard from that. Essentially, this is the SQL syntax for streaming tables. You create a refresh streaming table, you give it a name, and then the definition, and you can kind of see where we ingested the files from that directory and volumes. Same thing for that user data. I'm going to define the table, and I'm going to select the data as its types from those files that land there. And then what I want to do is I want to create a materialized view. So when you're building dashboards, it's super important to leverage materialized views because you're going to get the best performance on the BI dashboard with that. So this is kind of like looking through an end-to-end flow. And so here are our materialized views. We create that just by create materialized view. And then all of our data is created. Now let's go back into the catalog here, and we'll take a look at our database. And this is where all the data is. And now I want to leverage the consumption. So here's that materialized view. And let's say I wanted to have comments on it, like the AI suggested comments here from the generated documentation. I can go ahead and accept that. And maybe I want to do AI generate for those columns too. So I can go ahead and click AI generate. And now all of my metadata is complete. And as an analyst, this was super easy for me, right? I didn't have to do a whole lot of heavy lift, just a little bit of SQL. And then I was clicking through the UI, and I'm able to understand lineage. And it is other things in here too. If users are using it, you'll get insights. And then if you build in a data quality monitor, you can do that as well.
And the AI comments is like, it's super powerful because it's enabling the search. So you could be asking any question, and based on the comment, because the engine understands the data, like it's going to be able to find your table. And that's also powering like things like text to visualizations and things like that. For example, in the Lakeview dashboard. Is that right?
Yeah, let's go straight into it. Great segue, Quentin. Let's go straight into creating a dashboard out of this. So what I want to do is I want to go ahead and select that data, right? So here we go. So we have the user activities that I want to grab from there. So let's go ahead and grab that. Actually, I want to grab. So that's our table, and we'll see a little preview of that data right here as it's generating it. So awesome. These are our fields. We want to go ahead and select that. And let's go over to our canvas. So what I have here is my users table, and I have their age, risk, calories burnt, how many records, steps, and miles walked. So I know I want to get some graphics along those lines. So let's go ahead and go over here to the Lakeview canvas. And so what's really nice here is I can just ask it to generate my charts. So I want to see show users risk level and miles walked. And what Lakeview is going to do is it's going to understand my question, and then it's going to build me a visualization. Uh, chart user miles walked by risk factor. There we go. So we see average numbers of miles walked by their various risk factor. I also want to see chart steps taken by age. And here it shows the total number of steps taken by age group. So I can understand what's the activity levels of my user group. And this is synthetic data. I just want to call that out real fancy because it's kind of synthetically generated data. But this is how easy that you can create a dashboard. And let's say I want to give it a name. So I'm going to say activity tracker, age, and risk factor analysis. And I want to publish my dashboard. Awesome. I published my dashboard, and there it is.
All right, awesome. So let me do a recap of what we like of what you did. So you had files in the volume, raw files, raw JSON. Just writing a bunch of queries, SQL queries. You can ingest incrementally the data, meaning that every time you have a new data, you can just rerun it, or maybe just based on some trigger on files are reval, you rerun the job, which is going to incrementally add the new data. Refresh the materialized view at the end in your consumption schema, which is what you give to the analyst. And then as an analyst, it's super easy to build any kind of dashboard. That's amazing.
Yeah, and it's not done yet. There's just one more thing I want to show you that I think is one of my favorite things about Databricks. So not only can you build a Lakeview dashboard pretty simply, right? But let's go back to the catalog real quick. One of my favorite things about this is that if you have, let's say, a business partner that had an issue with the dashboard, right? And they said, I need to understand what happened. You can actually go into Lineage here and for that table, and you can see exactly which dashboards are impacted by this table. And so this helps you understand blast radiuses of issues, right? So if all of a sudden you have an issue with a pipeline, you understand, oh my gosh, how do I understand what are my downstream impacts of this? Well, you come straight over here and you can see exactly where that is. Okay, well, what notebook produced that? All right, let's go over notebooks. This notebook produced that code. I'm going to share this tab instead. So this notebook produced that code, and that pipeline fed this dashboard, so I know exactly what my blast radius is, right? And then what about all of the queries that are tied to there, or the models? So with Unity Catalog, when you leverage the best parts of Databricks together, trying to do root cause analysis, like one of the most contentious things in business today is why is this data wrong and how fast can we fix it, right? And what is the blast radius? When I was a practitioner in industry, something like this would take an FTE like 10 to 12 hours a week just to do root cause analysis. I did it in a few seconds, right? I didn't have to track through code. I didn't have to look through different systems. It's all right here in the UI.
Yeah, and I think it's also super powerful for things like governance. If you want to track the potential impact, even if you have just PII information that got leaked, like it's super easy to do it that way also.
So that's kind of what I wanted to share with you today, Quentin. Hopefully that helps.
Amazing. Yeah, it was awesome. Well, thank you, Franco. Thanks for the demo. It was amazing. And yeah, let's just get started with Databricks SQL.